Hi everyone, today we are taking a look at Unit 2, Lesson 4, Classifying Shapes. So we're going to continue to build on the information we have about the distance formula, which provides the length of a line segment, to help us classify some different shapes. First, we're going to take a look at all different types of triangles, and then we're going to look at different four-sided figures and how we can classify them based on slope and based on length. So in this lesson, you might have to pause to write down some of the notes within the table on the front and the back of the sheet. I already typed in the notes. We'll chat about it, but you might need to pause to fill in the table. So the first type of triangle that we're going to look at is a scalene triangle. And if we can remember what a scalene triangle is, it's basically a triangle where all the sides are different lengths. So we'll use our tick marks to show any sides that are the same length. So one tick mark means that side is unique from the other ones because one side has 2 tick marks and one side has 3 tick marks. Also, all of their slopes are going to be different. None of them are running in the same steepness or in the same exact angle of direction. An isosceles triangle is a triangle where 2 side lengths are the same. So we'd say like this side and this side are the same. So we'll put the same amount of tick marks on that side of the triangle so you can see they're the same. And then those 2 are going to be different from this third side here. And again, all of your slopes are different for an isosceles triangle. An equilateral triangle, all 3 sides are going to be the same. So we'll represent that with 1 tick mark, meaning all 3 of those sides are the same. For a right angle triangle, you could either have an isosceles triangle or you could have a scalene triangle. We do know that our hypotenuse is always opposite our right angle. So this is always our longest side. So we can't have an equilateral triangle because this is always going to be longer than the other 2 sides. But we could have it where this side and this side are the same, or these are different sides. So I don't even want to leave those there because really you could either have those be the same or different. What we do know about the slopes of a right angle triangle is that 2 slopes are negative reciprocals. So 2 of the slopes are negative reciprocals. They're perpendicular to each other. Okay, and I just want to remind you that in math we represent something being perpendicular using this math symbol that looks like an upside down T. So we can see that if we had to point out this side and this side, they're perpendicular to each other. So they're going to have negative reciprocals of each other. So let's take a look at an example and how we can classify certain characteristics of this triangle. So a triangle has vertices -4, -1. Point B is at 2, 1, and point C is at -6, 5. Determine what triangle we have. So we're going to try to determine, is it scalene, isosceles, equilateral? Could it possibly be a right angle triangle? So we're going to do all this with algebra, but let's just do a rough sketch of this triangle. So if I was going to draw a plane, okay, and we're going to say that -4, 1, let's say is going to be somewhere here. And point B is at 2, 1, so let's say somewhere here. Just a rough sketch. And C is going to be at -6 and 5. So we'll say C is at -6, 5. Okay, we have some type of triangle. We need to determine what kind of triangle do we have. And so the way that we're going to do that is we're essentially going to set up a table and we're going to take a look at the length and the slope for all side lengths of this. So we have 3 different side lengths of our triangle. We have side length AB, we have side length BC, and we have side length CA. All right, and we want to determine, are any of the lengths the same? Because that will tell us what type of triangle we have. And then we need to also take a look at their slopes because that will let us know if we have any right angles in our triangle. So let's just create our own table here. All right, so if we're going to do our length of AB, we're going to use our distance formula. So the length of AB Remember, that is squaring our run and squaring our rise and adding them together. So our x values of a and b are negative 4 minus 2 squared, plus our y values of a and b are negative 1 minus 1 squared. So we'll just work our way through simplifying this. Okay, negative 4 minus 2 is a negative 6 squared, and a negative 1 minus 1 is a negative 2 squared. So we'll continue to simplify. We have 36 plus 4, and that is going to be square root or radical 40. Okay, let's go ahead and see if we can also figure out the slope of AB. So slope of AB is going to be my change in my y. So my y's are 1 minus a negative 1 all over 2 minus negative 4. So my slope of AB is going to be 1 minus a minus is a plus, so we'll have 2. And same on the bottom, 2 minus a minus is going to become a 2 plus 4, which is 6. And we're always going to reduce that to its lowest term, which is 1/3. Okay, take a minute and see if you can determine the length and the slope of line segment BC, and then also CA, slope and length. And then we'll come back and we'll kind of discuss what are the similarities, what are the differences, and what does that tell us about the type of triangle we have. Okay, so hopefully you were able to substitute in to determine the length and the slope of line segment BC, and then the length and the slope of line segment C and A. So if we take a look first just at our lengths, I have to see, is there anything similar about our lengths? Are any of them the same? And hopefully we can see that we have a radical 40 here, or square root of 40, and a square root of 40 here. So we can see that 2 of the sides are the same length. So if we have 2 sides that are the same length and our third side is different, we know we have an isosceles triangle. Then we can take a look at our slopes. So we can see that the slope of AB is 1/3. So no similarity or negative reciprocal with BC, because BC is negative 1/2. But if we look at the slope of CA, okay, the slope there is a negative 3/1. So we have a negative reciprocal to the slope of AB. So these are negative reciprocals. And remember, a negative reciprocal tells us that these 2 lines are going to be perpendicular. It means those 2 lines are perpendicular. So what can we conclude from calculating the slope and the length of all these? Well, we can say since, so remember, since is those 3 dots that make an upside down triangle. Since 2 of the sides are equal in length, which was the square root of 40, and 2 of the slopes are negative reciprocals, the triangle is a right angled isosceles triangle. Right, 2 of the sides are the same, so it is isosceles, and because 2 of the sides make a right angle, which we can see from those negative reciprocal slopes, then we know we have a right angle in that triangle as well. Okay, so that's how we can kind of determine what the triangle is in terms of its side lengths and if there are any right angles in a triangle. Now we're going to take a look at 4-sided figures. And again, you might need to pause to fill in the table, but let's just recall what we know about parallelograms. So in terms of their lengths, parallelograms have opposite sides that are the same length. So if we were going to just quantify that, we could say this side and this side are the same length, and then these sides that are opposite, okay, those are going to be the same length. If we take a look at their slopes, opposite sides have the same slope. So I'm going to use red to show how we denote if the slope is the same. So we could say that this slope on this side, which I'll show with an arrow, is the same as this slope on this side. So I'll draw again one arrow. That means those slopes are the same. But then the opposite sides, the slopes are the same. So I'll draw two arrows now because it's going to be different from the side length touching it, but it's going to be the same as the side length opposite it. Okay. When we look at a rectangle, we're going to have opposite sides have the same length again. So this and this side are going to be the same, and then my two vertical sides will be the same. Opposite sides have the same slopes. So similar to a parallelogram, where we could say this side and this side have the same slope, as well as my two horizontal sides are going to have the same slope. One additional feature about a rectangle, which we'll see with a square as well, is that adjacent sides are negative reciprocals, which means they are perpendicular. So these two sides are going to make a right angle. And I just want to grab this text, and looks like some of it's hidden a little bit. Make that a little bigger, okay. So if we take a look at rhombus, it says all sides have the same length. So we're going to give it the same tick marks all around because they're all going to be the same. Opposite sides have the same slope, so they're parallel. So once again, we could say that this side and this side have the same slope, and then our horizontal sides will have the same slopes. Taking a look at a square, again, all side lengths the same. Opposite sides are parallel, so they have the same slope, and then again, my horizontal sides are going to have the same slope, and then also we're going to have right angles, right? All these are going to be negative reciprocals of each other, so they're all going to be negative reciprocals. They'll be right angles. Finally, if we take a look at a trapezoid, the parallel sides are different in lengths. So a trapezoid could look like this. We could have a trapezoid that looks something like this, where this side is clearly longer than the side opposite it. But what is going to be always consistent is that the top and the bottom, essentially, of the trapezoid are going to be parallel. So and they're going to be different in length. So this side, oops, I want a blue for that. So this side and this side are always going to be different in length, but they are going to be parallel. So they are going to have slopes that are the same. Okay, so we're going to look again at an example, and we're going to see if we can identify what four-sided figure we're dealing with based on length and based on slope. Okay, so pause if you need to finish filling out that table, and then let's set up this example. So we have a quadrilateral. It has the vertices provided here, A, B, C, and D. Determine the type of quadrilateral we have. So again, we could draw a rough sketch of this, but we are going to use length and slope to help us determine what kind of quadrilateral we have. So our first point is at -9 and 7. So we'll put that somewhere over here. Okay, our next point is at -14 and 19. So we'll put that somewhere over here. And then C is at -2 and 24. And then we have 3 and 12. So we'll put that somewhere over here. I didn't mean to. Just clean that up a little bit. Okay, so we can just do a rough sketch. Again, this is just not drawn to scale or anything, but you can see maybe we have a parallelogram, or looks like maybe a rectangle turned on its side. We're not too sure. So we're going to set up the same table we set up with our triangles, and we're going to determine the length and the slope of all of those side lengths. So we have AB, we have BC, we have CD, and then we have finally DA. So we're going to have to determine the length, and we're going to have to determine the slope. So set up your table just like we did on the front. Lots of calculations, but you're essentially just repeating the formula over and over again. So I'm going to take you through doing it with AB, and then you can pause the video and do it with the other three sides of the four-sided shape. So our length of AB, we're going to be working with point A and point B for all of our calculations here. Remembering what the the length formula is. So the length of AB is going to be the square of your run plus the square of your rise added together. So our run is going to be our x values. So we have a -9 minus a -14 squared, plus our y values are 7 minus 19 squared. Lots to fit in this tiny little box. So a -9 minus a minus is going to be a plus. So a -9 plus 14 is going to be 5 squared. And 7 minus 19 is a -12 squared. So we'll just continue to simplify this. So we'll have 25 plus 144. So the square root of 169. So our length of AB is going to be 13. Okay, so we know this, the length of that side. Let's work to find our slope. So the change in my y, so my y's are going to be 19 minus 7 all over -14 minus -9. So 19 minus 7 is going to be 12. -14 minus a minus, we're going to have a plus. So that's going to be -14 plus 9 is a -5. All right, so we know the slope is a -12/5, and our side length AB is 13. So pause the video, work through the calculations for all those other sides. So what's the length, what's the slope of BC, CD, and DA? And then we'll come back together and see if we can try to determine which four-sided figure we're working with. Okay, so hopefully you were able to calculate the length and the slope of each of these additional lines. And now we have to take a look at what's similar, what's different, what does that tell us about this four-sided figure. So hopefully we can look at the side lengths first, and we should have gotten that each of the side lengths was exactly the same. So each of those side lengths looks to be 13, so same lengths. And maybe I'll just put here all sides. Okay, all sides are the same length. So if we know all sides have the same length, we only have two shapes up here that are like that. So we either have a rhombus or we have a square. So the only difference between a rhombus and a square is this part right here, it looks like. So are the adjacent sides negative reciprocals? Because in a rhombus they're not, but in a square, adjacent sides are negative reciprocals, which shows that they're perpendicular, which gives us that square. So if we look, AB would fall next to BC. Are they negative reciprocals? So 12 over -5, 5 over 12, yep, those are negative reciprocals. So that shows that they're perpendicular. And then if we look at CD and DA, -12 over 5 and a +5 over 12. So again, those are perpendicular, right? We have negative reciprocals there. So if we have negative reciprocals and all side lengths are the same, we should be able to deduce then that we're dealing with a square. So let's just summarize what we found and say why we think then that it's a square. So we can say, since the lengths are all the same, so they're all 13, and opposite sides have the same slopes. So what I mean by that is side lengths A and B and C and D, right? Those have the same slopes, as well as BC and DA. And then we also know adjacent sides are perpendicular. Right, and we can just show it with that math symbol. We can say then, therefore, this four-sided shape is a square. Okay. Negative reciprocal slopes, all side lengths are the same, we're dealing with a square. So you'll continue to practice being able to identify triangles or four-sided shapes based on the length of the sides and what's going on with the slopes. That's all for your note for today.